In addition to the coding that we saw on the condition parameters for the execute statement, we can also code the condition parameter on the job statement, which would then apply to any step within that job, which would then result in a termination of the job if that condition code test is met. This is less frequently used these days, but it is something that can be quite useful if you have multiple steps and you're not quite sure what the completion is going to be, and rather than coding a bunch of dependencies in your execute statements, you simply say that if any of the steps gets a return code 12, for example, I simply want to terminate the job, and then I'll check it out and determine what action to take. So this is a way of basically allowing the global specification of a particular check. So in this case here, the job specification does take precedence over anything that would be on an execute statement. And as a result, we are looking at the overall status for the entire job. That's what the purpose of this is. Now, besides those condition parameters, we also have another way in which we can use conditional logic. And in this particular instance, what we're able to do is we actually have an if and end if construct that we can use within our JCL. In this particular example, what we're able to do is we're able to use if statements and identify the particular step in a return code, and then set a specific test, like less than 4, then we want to execute the following step. Otherwise, we want to go and execute something else. And we can use this if and end if as a way of introducing some logic, something that might be more familiar to people that are doing programming code. This method is a little bit more intuitive. Unfortunately, a lot of the original condition parameters have been around for a long time, so even if you have the opportunity to use this, you may still run into a significant amount of JCL that has the standard condition parameter coded. So even though this is a good alternative, it may not be something that you've run into very frequently. The operators that we have in this case allow us to add and create some logical connections so that we can use a not indicator to negate a particular test. We can use our standard greater than, less than, we can employ symbols, and we can use connectors for and or logic, so that in that case we can involve a combination of events that we want to use as part of our testing. Additional conditional tests that can occur involve testing for abend situations, just as we saw with the condition only and even. However, we can also determine whether a step did not abend. We can also check for a specific step which the condition even or only does not provide. Even and only is generic, in other words, any previous step, and we can test that condition. But in this case, we can be very specific in testing a specific step. We can also check for a very specific system condition code. So in this case, we are not stuck with just accepting any abend condition, but we can check for very specific ones that we would want to take a look at or consider some action on. We can also establish whether a step ran, in which case what we're dealing with is we're dealing with a step that might have been bypassed because of a restart, or potentially that didn't run because of a previous condition code setting. We can test for that condition, as well as we can test for whether or not a step did not execute at all. This gives us a tremendous amount of flexibility in determining which steps should or shouldn't run. Now, a lot of this sounds very good, and it certainly provides you a great deal of control in testing previous conditions to determine what's running. However, as a practical matter, a lot of times you simply don't need that much control. If a step fails, there's not much that you're going to do about it within your JCL. So unless you have steps that are coded to specifically execute because of a particular problem, then it might be useful to do this. But if you don't know, or if you don't have anything specific that you want to do, then simply allowing the termination and following your restart procedures and correcting the problem may be the best course of action. So even though we have a fair degree of control in establishing previous conditions, that doesn't automatically translate into a great deal of automation with respect to the job control itself. Also recall that our symbolic parameters that we were using with respect to setting values in a multiple step job can become a little bit more tedious. So we need to be careful about having too many symbols that might be used redundantly throughout the proc, because obviously if we change one value, we would change them for all. In addition, we could end up having multiple different symbolic parameters and simply make the entire process too cumbersome. So we want to make sure that we have good values that have a reasonable expectation of needing to be changed, rather than simply coding a whole bunch of symbols on the off chance that they might need to be changed. After all, if they need to be changed, we can always use an override JCL statement for those exceptional situations that occur. Symbolics should represent something that is easy, predictable, and reliable to use because of the fact that there's an expectation that it needs to be done. But for the one-off or for the once-in-a-while recovery situation, an override is perfectly adequate to take care of those situations rather than try to handle everything through the use of symbolic parameters. So the key here is don't overdo it. Don't get carried away with definitions because it makes the entire process much more confusion. A simple test is when you're looking at a JCL procedure and you have 20 or 30 symbols and you start looking at the JCL and it's hard to keep track of, that's a good indication that you probably have too many symbols in there and not enough good justification as to why they should all be there. A one-size-fits-all solution does not always work. Another thing to remember is, as we said, the override of JCL statements can often be useful, and in this particular case here, we are going to need to make sure that all of our execute statements have step names so that they can be referenced for override purposes as well as for restart purposes. We need to be able to identify the step name and the DD name for a particular override. This requires that we have unique names. Otherwise, we will end up with problems in our JCL because the override won't be able to find a unique entry for the override to be applied to. Any override that is specified after a particular step name, if it does not have the step name included, will simply be applied to that particular step. So I don't have to code the step name on every statement, but I do need to code it on any statement where I want to direct it to a specific step. There's no harm in coding it, but there's no harm in leaving it off when it can be positioned properly. And any DD statement that does not exist in the proc will be treated as a new entry within that step. So as we saw in the assembly link and go, when we had our c.sysin, since there was no sysin DD statement identified, it was added as a new entry within that particular step. This pretty well addresses most of the coding requirements that we have and the considerations for JCL. Everything ranging from our job statement, execute statement, DD statement, the ability to have multiple steps, the ability to use overrides and symbolic parameters in order to deal with stored procedures that we are using. In the next several units now, what we are going to be looking at is we are going to be looking at the role of generation data sets, which are a particular type of data set that we may want to use for our data set names, as well as exploring the utility programs that are provided for us to be able to perform certain base functions within ZOS.